All right, guys. Um, Welcome back to another YouTube video. Thank you guys for the support so far by subscribing and also by commenting sometimes and asking questions as it pertains to these lessons. Today we're going to look at just a typical graphing question relating to simple pendulum for the most part. The main concept behind this is really for us to understand how to linearize a typical equation, so to speak, so that we can plot a particular graph and then use the graph to find out different information. All right, so that's kind of like what we want to do at this point in time. And so if you look right here, it is telling us that we have a simple pendulum, and of course this is the typical equation that we use to find the period, that says t is equal to 2 pi times the square root of L divided by G. All right, now the question went ahead and said that a graph is plotted with t square on the y-axis, so we can even go ahead and label that. We can go ahead and label that this side is t square. All right, and we can put our units. So that will be our units, and it went ahead and told us that length is on the x-axis, and of course that is going to be in meters for the most part. All right, now the graph here is going to be a straight line graph. Obviously we expect a directly proportional relationship between t square and L, and that's the reason why we generally would have to linearize the formula. And what we mean by linearizing the formula, we will essentially be making it into an equation of a straight line. All right, and a typical equation of a straight line is y is equal to mx plus c. Okay, so our aim really is to plus c rather, sorry, is for us to take this equation and make it appear as a y called mx plus c equation. Now in order for us to do that, we need to ensure that we are able to see our variables that will be going on the graph. So of course the equation must be showing t square, and it must be showing L by itself. By way of looking at the equation, we're already seeing t, we're seeing L, but L is being square rooted. All right, now the easiest thing for us to do to make this into a linear equation for the most part is to simply square both sides of the equation. All right, so we're going to square both sides of the equation. The reason why we square both sides of the equation, we're simply trying to get rid of the square root sign, because the square root sign is stopping us from finding L, or making L become by itself, so to speak, because we want L by itself, you know, and the square root is stopping us from making L a single variable by itself. So when we do that, we get t square here. Now in any case, when you're squaring both sides, all the variables are being squared for the most part. So the 2 is being squared, and that gives you 4. The pi is being squared. Square root and square cancel each other, so we're now left with L divided by g. So at this point, the equation is somewhat linear in this case, right? We can see that t square is our y variable, and we can also see that x is by itself, and well, not x, but L is by itself, and that is actually our x variable. Now, if you look at a typical equation of a straight line, beside the x variable is the m value, and that m value is what we consider to be the gradient. Now, it simply means that anything that is left beside the x variable, that will now become the gradient value, so to speak. So if we compare right here, all of this that is remaining corresponds to m, which is the gradient, right? So you could go ahead and just write this to say m is equal to 4 pi squared divided by g, right? So we just kind of want, we're matching variables for the most part. It's kind of like that, all right? So we just this is kind of like the most important thing for us to see that the gradient value m is going to be equal to 4 pi squared divided by g. This is going to become very useful when we try to find the value of g from the graph. So if we go ahead and complete this table, we need to calculate the value of t and the value of t squared. The question said that a student measures the time t for 10 oscillations for different length L, or different lengths L. So we have the lengths here, we have the time that it takes to complete 10 oscillations. Now, students, the reason why in a typical simple pendulum experiment you would measure 10 oscillation is simply to get a more accurate reading for one oscillation, right, or one period, because you know it's an experiment that we're doing, right, and it's so hard to measure one oscillation. So the easiest way to do it is to get an average, right, or get a total of 10 oscillations, and then to find out the time taken for one oscillation, then you simply divide the total time for 10 oscillations by the number of oscillations. So a typical formula that we can come up with sometimes is to say that the period, right, t, and period, guys, is just the time taken to complete one oscillation. So, and that can be documented as this. So imagine that we have a pendulum and it starts to swing from this standpoint, right? So this is the starting point. One period would be the time it takes for the pendulum to swing back to where it started. All right, so that would be considered to be the period. Now, because we are measuring 10 oscillations, to find out the period, which is one oscillation, it would be for us to take the time for 10 oscillations and divide that by the number of oscillations. And so, with that being said, our period is going to simply be us dividing the 11.1 by 10, and that gives us obviously 1.11. And we're going to do this for all the others. Of course, I'm going to break the video just finish this part, and then we come back with the others. And the same thing applies for, I mean, well, t squared is quite simple. We just square the value of t, right? Or we just square the value of the period. So let me just double check. So 1.11 squared is going to be 1.2. All right. So complete the rest of it, and then we go straight into plotting our graph afterwards.